Now here the question is, from a point 0, 3 on a circle, x square plus 4x plus y minus 3 equals 0, a chord AB is drawn and extended to point M such that AM equals to AB. We have to find equation of locus of M. So we have this circle and we are given a point A and this point is 0, 3 and that's your chord AB. Now AM is 2 times AB. So this is your point M. We have to find locus of M. So suppose this M is alpha comma beta. Now B is midpoint of AM. So this B can be expressed as alpha by 2 and beta plus 3 by 2. Now this point B will lie on this circle. So we'll put the value of x and y. So it will be this alpha square by 4 plus 4 alpha by 2 and plus y minus 3. So it will be this beta plus 3 by 2 minus 3 square. It is equal to 0. Now this is alpha square plus 8 alpha and plus beta minus 3 whole square equals 0. So this equation will be x square plus 8x plus y minus 3 whole square and will be equal to 0, and that's your option B. Now the question is, two thin rods AB and CD of length 2A and 2B move along x-axis and y-axis. The equation of locus of center of circle passing through extremities of these two thin rods. Now we'll draw this circle. Now we have this circle which pass through extremities of these two rods. Now this is rod AB and that's your rod CD. Now we find locus of center of this circle. Now suppose center is at alpha comma beta. Now this distance it is mod beta and this distance it is mod alpha. Now this length is B and this length is A. Now we can find this radius. This radius R will be under root of B square plus alpha square, and here also we can write this radius and now it will be under root of A square plus beta square. So B square we can write alpha square minus beta square equals A square minus B square. So locus of this center will be this hyperbola, which is x square minus y square equals A square minus B square, and that's your option B. Now here the question is, locus of midpoints of chords of this circle which subtend an angle of pi by 3 at its circumference. So we are looking for locus of midpoint of chords, say this point, and since it is a locus problem, we'll take this point as some alpha beta. Now this chord, it subtends an angle pi by 3 at its circumference. That means at the center it will subtend an angle 2 pi by 3. Now this is pi by 3. Center of this circle is at minus 2 comma 3 and its radius will be under root of 4 plus 9 plus 12 and that will be simply 5. So that's 5. Now 5 is fixed, pi by 3 is fixed. So basically CP will be simply 5 cos 60 and that will be 5 by 2. Now CP is under root of alpha plus 2 whole square plus beta minus 3 whole square and it will be equal to 5 by 2. So this is alpha plus 2 square plus beta minus 3 square and 2.5 square is 6.25. Now we'll replace alpha with x and beta with y. So this required locus, it is this circle, x plus 2 square plus y minus 3 square and will be equal to 6.25, and that's your option B. Now here the question is, through a fixed point HK, secants are drawn to this circle. So we have this fixed point HK from which a secant is drawn. Show that the locus of midpoint of portions of secant intercepted by this circle is this value. So we have to find locus of midpoint of these chords. Now since this is locus problem, first step is identify the point. So let this point be alpha beta and it is this midpoint, and we know that equation of chord is given by t equals s1. Now this is alpha x plus beta y minus r square, and will be equal to alpha s square plus beta s square minus r square. Now this r square will cancel. Now this chord will pass through h comma k. So we'll put the value of x and y. So we'll get h alpha plus k beta equals alpha s square plus beta s square. Now in the end we'll replace alpha with x and beta with y. So this required locus will be this circle x square plus y square minus hx minus ky equals 0, and which is what we need to prove in this question. Now here the question is, if a pair of perpendicular lines passing through this point 1, 4 intersects x-axis at q and r, then locus of in center of triangle PQRS. Now here we have our coordinate axis, and then we have this point at 1, 4, and it says pair of perpendicular lines passing through this point P intersects x-axis at Q and R. We have to find locus of its in center. So we have this in circle, and we have to find locus of in center. Now suppose this point is I, and it is given by h comma k. Now this is 90, this is 90, this is r, and this is also 90 degrees. This is r, so this length is also equal to r. And since this circle, it touches x-axis, that means this r will be equal to k. And this distance pi, it is r square plus r square, and there will be under root 2r, which is root 2k. Now we have p and we have I. We can write this distance pi, and there will be under root of h minus 1 square plus k minus 4 whole square, and will be equal to root 2k. And if we square it, we can write h square plus 1 minus 2h plus k square plus 16 minus 8k equals 2k square. So we can write this as h square minus k square minus 2h minus 8k plus 17 equals 0, and in the end we'll replace h with x and k with y. So this equation will be x square minus y square minus 2x minus 8y plus 17 equals 0, and that's your option C. Now here the question is, triangle formed by the lines x plus y equals 0, x minus y equals to 0, and lx plus my equals to 1. If L and M vary subject to the condition that L square plus M square equals 1, then locus of its circumcenter is. So we have our coordinate axis, and then we are given two lines. This is y equals x, and then we have x plus y equals 0. Now this is 90, center is at origin, and then we have a variable line which is Lx plus My, and it is equal to 1. Now suppose these points are A and B. Now we can find coordinate of this point A. If we put x as y, then this point will be 1 upon L plus M and 1 upon L plus M And here if we put y as minus x, then we'll get this as 1 upon L minus m and minus 1 upon L minus m. Now we have to find locus of circumcenter. Now this is a right angle triangle. So its circumcenter will be midpoint of AB. So let this point be M, and suppose it is given by H comma K. So now we can write 2H equals 1 upon L minus M plus 1 upon L plus M. So there will be 2L upon L square minus M square, or this H is L upon L square minus M square. And for y coordinate we can write 2k, and there will be minus 1 upon L minus M plus 1 upon L plus M. So there will be minus 2m upon L square minus M square, or this k is minus m upon L square minus M square. Now we square them and subtract them, we can write H square minus K square, and there will be L square minus M square upon L square minus M square whole square. Now I'll cancel once, so it is equal to 1 upon L square minus M square. And if we square and add them, then we can write H square plus K square equals L square plus M square upon L square minus M square whole square. And it is given that L square plus M square is 1, so it will be 1 upon L square minus M square whole square. Now we'll substitute this value here, so we'll get H square plus K square equals H square minus K square whole square. So this required locus will be x square minus y square whole square, that is equal to x square plus y square, and that's your option A. Now here the first question is, whatever with the value of alpha, prove that locus of intersection of straight line is a circle. So we have two lines, x cos alpha plus y sin alpha equals A, and x sin alpha minus y cos alpha equals B. Now here alpha is a parameter and point of intersection is, suppose xy itself. I don't want to change it in hk and then change it again to xy. Now we have to eliminate alpha. So what we'll do is we'll simply square and add the two equations. So here it is x square cos square alpha plus y square sin square alpha plus 2xy cos alpha sin alpha, and that will be equal to a square, and here will be this x square sin square alpha plus y square cos square alpha minus 2xy sin alpha cos alpha, and that will be b square. Now if we add them, this 2xy term will cancel. Now cos square theta plus sin square theta is 1, so we'll get this as x square plus y square equals a square plus b square, and that's your required locus, which is a circle. The locus of a point which is such that tangents from it to the two given concentric circles are inversely as their radius is a concentric circle, the square of whose radius is equal to sum of squares of radius of two given circles. So we have two concentric circles, say, which are x square plus y square equals a square and x square plus y square equals b square. Now it says tangents are inversely proportional to their radius. So that means under root s1 upon under root s1 dash will be equal to b upon a, or simply s1 upon s1 dash is equal to b square upon a square. Now s1 is alpha square plus beta square minus a square, where this point p is, say, alpha beta, and s1 dash is alpha square plus beta square minus b square, and that will be equal to b square upon a square. Now we simplify this, we can write a square minus b square alpha square plus beta square will be equal to a to the power 4 minus b to the power 4. Now a square minus b square will cancel. So this required locus will be alpha square plus beta square equals a square plus b square, which is this circle. X square plus y square equals a square plus b square, and center of the circle is again at 0, 0. So it will be concentric to the two given circles, and its radius square is a square plus b square, which is sum of squares of radius of the given circles, and which is what we need to prove in this question. Now here the question is, prove that center of similitude of two circles, that is locus of the point at which two circles subtends the same angle, is a coaxial circle. Now we have two circles which are x square plus y square minus 2kx plus delta equals to 0, and x square plus y square minus 2k dash x plus delta equals to 0. Now here center is k comma 0 and radius is under root of k square minus delta, and here center is k dash comma 0 and radius is under root of k dash square minus delta. Now both the circles they subtend equal angle at this point P. We have to find locus of this point P. Now suppose this point is alpha beta. Now if this is theta, then this is theta by 2, and here also this is theta by 2. Now this is R1 and this is PA, and this is R2 and this is PB. Then we can write tan theta by 2 as R1 upon PA, and that will be equal to R2 upon PB. So we can write PA upon PB will be equal to R1 upon R2. Now PA is length of tangent, so it will be this under root of alpha square plus beta square minus 2k alpha plus delta, and here will be this under root of alpha square plus beta square minus 2 k dash alpha plus delta, and will be equal to under root of k square minus delta upon k dash square minus delta. Now we square it, we can write this as alpha square plus beta square minus 2k alpha plus delta upon alpha square plus beta square minus 2 k dash alpha plus delta, and will be equal to k square minus delta upon k dash square minus delta. Now we know that if a upon b equals c upon d, then a upon a minus b will be equal to c upon c minus d. So we can write alpha square plus beta square minus 2k alpha plus delta upon, and if we subtract this, we can write minus 2 alpha k minus k dash, and this is equal to k square minus delta, and it is k square minus k dash square. Now k minus k dash will cancel, so we'll get alpha square plus beta square minus 2k alpha plus delta upon minus 2 alpha, and that will be equal to k square minus delta upon k plus k dash. Now we can rearrange this as alpha square plus beta square, and then minus 2 alpha, and this is k here, and then it will be k square minus delta upon k plus k dash, and plus delta equals 0. Now it will be this alpha square plus beta square minus 2 alpha. Now here k square will cancel, so it will be this k dash plus delta upon k plus k dash plus delta equals to 0. So locus of this point P will be x square plus y square minus 2 k dash plus delta upon k plus k dash x plus delta equals to 0, and which is what we need to prove in this question. Now here the question is the locus of point of intersection of tangents to this circle at the extremities of the chord of the circle which touches this other circle is. Now since this is a locus problem, first thing is identify the point. So we'll let this point is P, alpha beta. Now from this point, tangents are drawn to this circle and we have this chord of contact, and we know that chord of contact is given by t equals 0. So equation of chord of contact, there will be alpha x plus beta y minus a square equals to 0. That says this chord, it is tangent to this circle whose center is at a comma 0 and radius is a. So perpendicular distance from center must be equal to its radius. So we'll get alpha a minus a square upon under root of alpha square plus beta square, and they'll be equal to a. Now this a will cancel. If we square it, we'll get alpha square plus beta square equals alpha minus a whole square, or it will be this beta square equals a square minus 2a alpha. So this required locus, it will be y square equals, we'll take a common, and there'll be this a minus 2x, and that's your option A. And since it is a multiple choice question, we can substitute xy here also. So it will be this x square plus y square, and this is x minus a whole square. That means the correct options are A and C. Now here the question is, tangents are drawn to the circle x square plus y square equals to 1 at its intersection point with this variable circle. The locus of intersection of tangents is a straight line, then slope of that straight line is. Now we have to find locus of intersection of tangents. So let this locus be this point P, which is alpha beta. From this point, tangents are drawn to this circle. So we can write equation of chord of contact, and that will be given by t equals to 0, and it will be this alpha x plus beta y minus 1 equals 0. Now this chord of contact is actually common chord between the two circles. So we can write this equation using radical axis. So for the two circles, we'll write radical axis. So we subtract second from first, we'll get this equation as lambda minus 3x plus 2 lambda plus 2y, and then this is plus 2 plus 1. So plus 3 equals 0. Now both the equations, they represent the same line. So we get alpha upon lambda minus 3 equals beta upon 2 lambda plus 2, and this is equal to minus one by 3. Now what we'll do is we'll eliminate lambda here. So we'll get minus 3 alpha equals lambda minus 3, or lambda equals 3 minus 3 alpha. And here we'll get 2 lambda plus 2 equals minus 3 beta, or lambda equals minus 3 beta minus 2 upon 2. Now we equate lambda, then we'll get 3 minus 3 alpha will be equal to minus 3 beta minus 2 upon 2. So we get 6 minus 6 alpha, that is equal to minus 3 beta minus 2, or equation of this line will be 6x minus 3y minus 8 equals to 0, and slope of this line is minus coefficient of x upon coefficient of y, which is simply 2. So answer to this question is slope of this straight line is 2. Now here the question is, a triangle has two of its sides along this axis, and its third side touches this circle whose center is at a comma a, and radius is equal to a. So this circle, it touches both the axes. Now we have a triangle whose two sides are along the axis and third side it touches this circle. Now suppose this is origin. Now let this point be P and this point be Q. So coordinate of this point is suppose P comma 0 and coordinate of this point is 0 comma Q. Now this angle is 90. So circumcircle of POQ will have PQ as diameter and its midpoint will be center of the circle. We have to find locus of circumcenter. So let this point be alpha beta. Now since alpha beta is midpoint of PQ, alpha is P by 2 and beta is Q by 2. Now equation of this line PQ. So equation of PQ will be given by x upon P plus y upon Q equals to 1. And since this line is tangent to this circle, that means perpendicular distance from the center must be equal to its radius. We get A upon P plus A upon Q minus 1 upon under root of 1 upon P square plus 1 upon Q square, and it will be equal to A. Now we can simplify this as A P plus Q minus PQ and be equal to A under root of P square plus Q square. Now we square it, we can write A square and there will be P square plus Q square plus 2PQ plus P square Q square minus 2APQ P plus Q, and that will be equal to A square P square plus Q square. Now A square P square plus Q square will cancel. So we'll get this as 2A square PQ plus PQ square minus 2APQ into P plus Q, and that will be equal to 0. Now here PQ will also cancel. So we'll get this as 2A square plus PQ minus 2A P plus Q equals 0. Now P is 2 alpha and Q is 2 beta. So we can write this as 2A square plus 4 alpha beta minus 2A 2 alpha plus 2 beta equals 0. So it will be this A square plus 2 alpha beta minus 2A alpha plus beta equals 0. Now we'll replace alpha with x and beta with y. So this required locus, it will be A square plus 2xy minus 2A x plus y equals 0. Now locus of circumcenter, it passes through this point which is 38 comma minus 37. So it will be this A square plus 2 into 38 into minus 37 minus 2A equals 0, or A square minus 2A equals 2812. So answer to this question is 2812. Now here the question is, a circle passes through the point A comma B and cuts this other circle x square plus y square equals to k square orthogonally, then equation of locus of its center. Now we will find equation of locus of its center. So let this point be alpha comma beta. Now for this other circle, center is at origin and here radius is say r and this radius is k. Now this is C1 and this is C2. Now since these two circles they intersect orthogonally, we know that C1 C2 square is equal to r square plus k square. Now C1 C2 square is alpha square plus beta square, and we can write radius of this circle in terms of alpha, beta and AB. So we're going to write this as alpha minus a square plus beta minus b square plus k square. Now here alpha beta they'll cancel, so we'll get a square minus 2a alpha plus b square minus 2b beta and plus k square, or this required locus is 2a alpha plus 2b beta minus a square minus b square minus k square equals to 0. Now in the end, we'll replace alpha with x and beta with y. So we'll get this equation as 2ax 2by and then minus a square plus b square plus k square equals 0. And that's your option A. Now here the question is, a circle with center at origin and radius equal to a meets the axis of x at points a and b. If p, alpha and beta are 2 points on this circle so that alpha minus beta is 2 gamma, where gamma is constant, then locus of point of intersection of AP and BQ is. Now we have this circle with center at origin and it meets x-axis at A and B. And its radius is a, so this a is a comma 0 and b is minus a comma 0. Now we have 2 points p and q on this circle. Now p is characterized by this alpha, so this p is a cos alpha, a sin alpha, and this q is characterized by beta, so it will be this a cos beta and a sin beta. Now it says alpha minus beta is given as 2 gamma, the locus of point of intersection of AP and BQ. So we have to find locus of point of intersection of BQ and AP. This point, and suppose this point is M, it is given by alpha beta. Now these points A, M and P, they are collinear. That means slope of AM must be equal to slope of AP. So slope of AM is equal to slope of AP. Now slope of AM is beta upon alpha minus A will be equal to minus A sin alpha upon A 1 minus cos alpha. Now this A and A will cancel. Now we can write this as 2 sin alpha by 2 cos alpha by 2, and this is 2 sin square alpha by 2. Now this 2 and sin alpha by 2 will cancel. So we can write beta upon alpha minus A, it is equal to minus cot alpha by 2. And that's our first equation. And the same way, B, M and Q, they are collinear. That means slope of BM must be same as slope of BQ. Now slope of BM is beta upon alpha plus A, and will be equal to A sin beta upon A 1 plus cos beta. Now here this is 2 sin beta by 2 upon cos beta by 2, and here it is 2 cos square beta by 2. Now here cos beta by 2 will cancel, so we'll get 10 beta by 2 as beta upon alpha plus A, and that's our second equation. Now in the question it is given that alpha minus beta equals 2 gamma, so we can write alpha minus beta by 2, it is equal to gamma, and if we take 10 both sides, then we can write 10 alpha by 2 minus 10 beta by 2 upon 1 plus 10 alpha by 2 into 10 beta by 2, and will be equal to 10 gamma. Now 10 alpha by 2 is A minus alpha upon beta. So we can write this as a minus alpha upon beta minus, and tan beta by 2 is beta upon a plus alpha, and here it is 1 plus a minus alpha upon beta into beta upon a plus alpha, and it is equal to tan gamma. Now if we simplify this, we can write this as a square minus alpha square minus beta square upon beta a plus alpha beta plus a beta minus alpha beta, and it is equal to tan gamma. Now alpha beta will cancel, so we'll get this equation as alpha square plus beta square plus 2a tan gamma into beta minus a square equals 0. Or we can write this as x square plus y square plus 2a tan gamma into y minus a square equals 0. Now here the question is, locus of midpoints of chord of contact of tangents drawn from the points lying on straight line to this circle is. Now we have this circle whose equation is x square plus y square equals to 9, and we have found locus of midpoint of chords. So this is this point M, say alpha comma beta, from a point on this line, say P, and let this point be h comma k, and this line is 4x minus 5y equals 20. Now once we have midpoint of a chord, we can write its equation, and its equation is given by t equals s1. So this equation will be alpha x plus beta y minus 9, and will be equal to alpha square plus beta square minus 9. This 9 and 9 will cancel, so we'll get this equation as alpha x plus beta y equals alpha square plus beta square. Now from this point we have drawn two tangents, then we know that equation of chord of contact is given by t equals to 0. So for this point we have to find t equals 0. Now t equals 0 is hx plus ky equals 9. Now both these equations, alpha x plus beta y upon alpha square plus beta square, they represent the same line. That means h upon alpha equals k upon beta, and will be equal to 9 upon alpha square plus beta square. So from here we can write h as 9 alpha upon alpha square plus beta square, and k as 9 beta upon alpha square plus beta square. Now hk, they'll satisfy this equation. So we get 4h minus 5k equals 20. So this equation will be 4 into 9 alpha upon alpha square plus beta square minus 5 9 beta upon alpha square plus beta square. It is equal to 20. So we'll get this equation as 20 alpha square plus beta square minus 36 alpha plus 45 beta equals 0. In the end, we'll replace alpha with x and beta with y. So this required locus, it will be 20 x square plus y square minus 36x plus 45y equals 0, and that's your option A. Now the question is, let ABC be a triangle whose vertices are minus 5 comma 5 and 7 comma minus 1. And if the vertex C lies on a circle whose director circle has equation x square plus y square equals 100, then locus of orthocenter of triangle ABC is. Now this vertex C, it lies on a circle whose director circle is x square plus y square equals 100. That means C will lie on this circle, which is x square plus y square equals 15. Now if we look at this point A, then if we put this A as minus 5 comma 5, then it will be 25 plus 25, it is 50. So this A will lie on the circle, and B also 7 comma minus 1 will lie on the same circle. So we have this circle with center at origin and all the 3 points, they'll lie on this circle. So we have this A minus 5 comma 5, B 7 comma minus 1, and then we have the C, which is suppose alpha beta, and suppose orthocenter of this triangle is at H comma K. Now circumcenter is at origin, so we have circumcenter at origin. We can find centroid, and centroid will be alpha plus 2 by 3 and beta plus 4 by 3, and we know that circumcenter, centroid and orthocenter, they're collinear, and G divides OH in the ratio 1:2. So basically we'll use section formula. So it'll be this H by 3 and K by 3 will be equal to alpha plus 2 by 3 and beta plus 4 by 3. So from here we can find alpha, and this alpha will be equal to H minus 2 and this beta will be equal to K minus 4. Now alpha beta will lie on this circle, so we'll put the value of alpha beta here. So this required locus, it will be H minus 2 square plus K minus 4 whole square, and it is equal to 50, or H square plus K square minus 4H minus 8Y minus 30 equals 0, or this equation is X square plus Y square minus 4X minus 8Y minus 30 equals 0, and that's your option A. Now here the question is, a circle of radius r passing through origin cuts the axis at A and B. The locus of foot of perpendicular from O to AB is this value, then find the value of lambda. So we have this circle which passes through origin and which intersects axis at A and B. And radius of this circle is r. Now it says, if the locus of foot of perpendicular from O to AB is this value, find the value of lambda. Now we'll join this AB and we have to find locus of foot of perpendicular on this AB. So let it be this point P, and let this point be alpha beta. Now what we'll do is, we'll first find equation of this line AB, and then we'll find these points A and B. So slope of OP, it is beta upon alpha. Then slope of AB, it will be minus alpha upon beta. Now once we have point and slope, we can write equation of AB. So we'll write equation of AB as y minus beta equals minus alpha upon beta x minus alpha. So we'll get this equation as alpha x plus beta y, and will be equal to alpha square plus beta square. Now we'll find their intercept. So this point A, it will be alpha square plus beta square upon alpha comma 0, and coordinate of this point B will be 0 comma alpha square plus beta square upon beta. Now this AB is diameter of the circle. So basically this AB, it is equal to 2r, and if we square it, we can write AB square will be equal to 4r square. Now AB square is alpha square plus beta square whole square upon 1 upon alpha square plus 1 upon beta square, and that will be equal to 4r square. Now we'll replace alpha with x and beta with y. So this required locus will be x square plus y square whole square into 1 upon x square plus 1 upon y square, and will be equal to 4 r square. Now we compare it with lambda r square, that means value of lambda is 4, and that's your option C. Now here the questions. We are given a circle whose center is at 0, 1 and whose radius is 1, which touches another circle C externally, which also touches x-axis. We need to find locus of its center. So we have this circle whose center is at 0, 1 and radius is 1 unit. We have to find locus of center of this circle which touches this circle and also x-axis. Now suppose center of this circle is alpha beta, and when it touches x-axis, it means its radius is equal to modulus value of its y coordinate, that is mod of beta. Now these two circles, they touch each other externally, that means C1 C2, it must be equal to R1 plus R2. Now C1 C2 is under root of alpha square plus beta minus 1 whole square, and R1 plus R2 is mod of beta plus 1. Now we'll square it. So we can write alpha square plus beta square plus 1 minus 2 beta will be equal to beta square plus 1 plus 2 mod of beta. Now beta square plus 1 will cancel. We'll get alpha square as 2 beta plus 2 mod of beta, or x square equals 2y plus 2 mod y. Now if y is greater than or equal to 0, then in that case it will be this x square equals 4y, and if y is less than 0, in that case it will be x square plus 2y minus 2y, that is we'll get x equals 0. We can take equality sign here also, because when y is 0, x is 0. So what we'll do is we'll write this answer as this curve x square equal 4y union center is at 0, y when y is less than or equal to 0. That's your option D. Now here the question is, an isosceles right angle triangle whose sides are 1, 1, root 2 lies entirely in the first quadrant with the ends of hypotenuse on the coordinate axis. If it slides, prove that locus of its centroid is 3x minus y whole square plus x minus 3y whole square equals 32 by 9. First we'll draw this triangle. With sides 1, 1 and root 2. So this length is root 2, this is 1 and this is 1. Now suppose this angle is theta. So here it will be root 2 cos theta comma 0, and this point will be 0 comma root 2 sin theta. Now these two angles, they are 45 degrees and this is 90. Now coordinate of this point, it will be this length, which is root 2 cos theta minus this length, which is 1 cos theta plus pi 4. And its y coordinate will be 1 sin theta plus pi 4. So this point, say C, and these are A and B. The C will be root 2 cos theta minus, now this is cos theta minus sin theta by root 2, and here it will be sin theta plus cos theta by root 2. Now this is 2 cos theta. So coordinate of this point C will be cos theta plus sin theta by root 2 and sin theta plus cos theta by root 2. Now we have to find locus of its centroid. Now suppose this locus is this point P, alpha comma beta. Now alpha will be 0 plus root 2 cos theta plus cos theta plus sin theta by root 2 whole divided by 3, and that will be 3 cos theta plus sin theta upon 3 root 2. In the same way, we can write beta, and that will be root 2 sin theta plus 0 plus cos theta plus sin theta by root 2 whole divided by 3, and that is cos theta plus 3 sin theta upon 3 root 2. What we'll do is we'll find cos theta and sin theta. So for cos theta, what we'll do is we'll multiply everything with 3 and then subtract second from first. So there'll be 3 alpha minus beta, and now here will be 9 cos theta minus cos theta. So there'll be 8 cos theta upon 3 root 2. In the same way, for sin theta, we'll multiply the second with 3 and then subtract first from it. So then it will be 3 beta minus alpha, and we can write this as 8 sin theta upon 3 root 2. Now we'll square and add them. We can write this as 3 alpha minus beta whole square plus 3 beta minus alpha whole square, and that will be 64 upon 18, and sin square theta plus cos square theta will be 1. Now this is 32 by 9. And in the end, we'll replace alpha with x and beta with y. So this required locus will be 3x minus y whole square plus 3y minus x whole square, and it is equal to 32 by 9, which is what we need to prove in this question. Now here the question is, find the locus of midpoints of all chords of the circle x square plus y square minus a square which pass through fixed point h comma k. Now this is locus problem. We have to find locus of midpoint. Now let this point be alpha beta. Now if midpoint is given, we know that equation of chord is given by t equals s1. So this equation will be alpha x plus beta y minus a square will be equal to alpha square plus beta square minus a square. Now this a square will cancel. Now this chord, it will pass through this point h comma k. So we get alpha h plus beta k and will be equal to alpha square plus beta square. In the end, we'll replace alpha with x and beta with y. So this required locus will be this circle x square plus y square minus hx minus ky equals 0. So that's your first question. Now the second question is, find the locus of middle point of chords of the circle which subtends a right angle at the point c comma 0. So we have this circle. And then we have a chord, say AB, and we will find locus of midpoint of this chord. So let it be this alpha beta, and then it says this chord, it subtends right angle at this point c comma 0. So we have a point, say c comma 0, and this chord, it subtends an angle 90 degrees here. Now let us suppose coordinate of B is a cos theta and a sin theta, and at this point AB, h comma k. Now since its midpoint is alpha beta, we can write alpha as h plus a cos theta by 2 and beta as k plus a sin theta by 2. So from here we write coordinate of this point A as 2 alpha minus a cos theta and 2 beta minus a sin theta. Now this point A, allow this circle, so we get 2 alpha minus a cos theta square plus 2 beta minus a sin theta whole square will be equal to a square, allow this circle, so we'll get 4 alpha square plus 4 beta square minus 4 alpha a cos theta minus 4 beta a sin theta, and here a square will cancel. So we'll get this as equal to 0. So the condition that we'll get here is alpha square plus beta square will be equal to a alpha cos theta plus beta sin theta, and that's our first equation. Now the second condition that is given is AP subtends an angle 90 degrees at this point, say P. Then product of slope is minus 1. So we can write K upon H minus C into A sin theta upon A cos theta minus C. It is minus 1. Now we know the value of H and K. So it will be this 2 beta minus A sin theta into A sin theta upon H minus C. So it will be 2 alpha minus A cos theta minus C into A cos theta minus C, and this is equal to minus 1. Now we simplify this, we can write this as, we'll take this minus sign here, so we'll write minus 2 beta into A sin theta plus A square sin square theta, and here it will be 2 alpha A cos theta minus 2 alpha C minus A square cos square theta plus AC cos theta minus AC cos theta plus c square. Now AC cos theta will cancel, and cos square theta plus sin square theta will be 1. So we can write 2 alpha a cos theta plus 2 beta a sin theta. Now cos square theta plus sin square theta will be 1. So we'll get this as a square plus 2 alpha c minus c square. Now alpha a cos theta plus beta a sin theta, it is alpha square plus beta square. So we'll get this as 2 alpha square plus beta square equals a square plus 2 alpha c minus c square. So this required locus is 2 x square plus y square minus 2cx plus c square minus a square equals 0, and that is the answer to this question. Now here the question is, locus of centers of variable circle touching two circles of radius r1 r2 externally which also touch each other is a conic. Now suppose we have two circles which touch each other externally, suppose at origin, then this point it is minus r1 comma 0 and this point is r2 comma 0, and then we have this circle whose center is h comma k and radius r. Now these two circles, they touch each other externally, that means c1 c2, and c1 c2 is under root of h plus r square plus k square, that is equal to r1 plus r, and here this is r1. And the same way, these two circles, they touch each other externally, so we get under root of h r2 square plus k square, and they'll be equal to r2 plus r. Now we subtract first from second, we'll get under root of h plus r1 square plus k square minus under root of h r2 square plus k square, and will be equal to r1 minus r2. Now suppose this point is P, this is A and this is B. So basically we'll get PA minus PB, that is constant, and it is equal to r1 minus r2, which is equal to 2A. So this point P will lie on a hyperbola. Now for this hyperbola A and B, they are its foci. So distance between foci 2AE, it is equal to r2 plus r1, and this 2A is equal to r1 minus r2. So this eccentricity E will be r2 plus r1 upon r1 minus r2, and we divide everything with r2, we get E as r1 upon r2 plus 1 upon r1 upon r2 minus 1. Now r1 upon r2 is 3 plus 2 root 2. So this eccentricity will be 3 plus 2 root 2 plus 1, and here will be 3 plus 2 root 2 minus 1. So this is 4 plus 2 root 2, and here it is 2 plus 2 root 2. Now here we'll take 2 root 2 common, we'll get root 2 plus 1, and here we'll take 2 common and we'll get root 2 plus 1, so we'll cancel. So eccentricity of this conic, which is a rectangular hyperbola, it is under root 2, and that's your option B. Now the question is, ends AB of a fixed straight line of length A and ends A dash B dash of another fixed straight line of length B slide upon axis of X and axis of Y, one end on X and other end on Y. Find the locus of the center of circle passing through AB, A dash and B dash. So we'll draw the axis, and then we'll have this circle. Now One of the rod is AB and another one is A dash, B dash. Now length of AB is A and length of A dash B dash is B. We have to find locus of center of this circle. Now suppose this angle is alpha and this angle is beta. So we can write coordinate of this point B as A cos alpha comma 0 and coordinate of A will then be 0 comma A sin alpha, and here this B dash will be B cos beta comma 0 and this A dash will be 0 comma B sin beta. Now we have to find locus of center of this circle. Now suppose this is H comma K. Now basically H is midpoint of BB dash and K is midpoint of AA dash. So we can write H as A cos alpha plus B cos beta by 2 and this K will be A sin alpha plus B sin beta by 2. Now here we have to eliminate alpha and beta. And here we have one more thing to our help, and that is these 4 points A, B, A dash, B dash, they are concyclic. And if they are concyclic, then OA into OA dash must be equal to OB into OB dash. That is AB sin alpha sin beta must be equal to AB cos alpha cos beta. That means tan alpha tan beta, it must be 1. That means alpha plus beta, it must be pi by 2. So we can write beta as pi by 2 minus alpha. So this H will be A cos alpha plus B sin alpha by 2, and here it will be A sin alpha plus B cos alpha by 2. Now here we have to eliminate alpha. So what we'll do is, from this equation we'll find cos alpha and sin alpha. So we'll write A cos alpha plus B sin alpha, it is equal to 2H, and A sin alpha plus B cos alpha, it is equal to 2K. Now we'll multiply this first equation with A and second equation with B and subtract. So we'll get A square minus B square cos alpha will be 2AH minus BK, or simply cos alpha is 2 times AH minus BK upon A square minus B square. And the same way we can find sin alpha. So there will be B square minus A square sin alpha will be 2BH minus AK, or sin alpha will be 2BH minus AK upon B square minus A square. Now we have to eliminate alpha, so what we'll do is we'll square and add. Now cos square theta plus sin square theta is 1. So then it will be this 4AH minus BK square plus 4BH minus AK whole square will be equal to A square minus B square. Now we'll replace H with X and K with Y. So it will be this 2AX minus 2BY whole square plus 2BX minus 2AY whole square, and that will be equal to A square minus B square whole square. Now here the question is, show that the locus of the point, the tangents from which to the circle x square plus y square minus a square equals to 0 include a constant angle alpha is the given equation. So we have this circle whose center is at origin and radius is a, and we have to find locus of this point P. These tangents, they make this constant angle alpha. So here this angle will be simply alpha by 2. This is A, and suppose this point is h comma k. Now once we have this A and alpha by 2, we can write OP, and OP is basically A cosec alpha by 2. Now we can write this OP as h square plus k square, and it will be equal to a square cosec square alpha by 2. Now we have to write this equation in terms of alpha, not alpha by 2. Now we'll write cosec square alpha as 1 plus cot square alpha. So here will be this h square plus k square minus a square, and will be this a square cot square alpha by 2. Or we can write tan square alpha by 2 as a square upon h square plus k square minus a square, or simply tan alpha by 2 as a upon under root of h square plus k square minus a square. Now we need this result in terms of tan alpha. Now we know that tan alpha is 2 tan alpha by 2 upon 1 minus tan square alpha by 2. So it will be this 2 a upon under root of h square plus k square minus a square upon 1 minus, and here will be this a square upon h square plus k square minus a square. Now we can write this as tan alpha, and here under root h square plus k square minus a square will cancel, so it will be this 2a into under root of h square plus k square minus a square upon, and here will be this h square plus k square minus 2a square. Now we square everything, we can write this as h square plus k square minus 2a square whole square into tan square alpha, and there will be 4a square h square plus k square minus a square. Now we'll replace h with x and k with y. So this required locus will be x square plus y square minus 2a square whole square into tan square alpha will be equal to 4a square x square plus y square minus a square, and which is what we need to prove in this question. Now here the question is, a variable circle passes through the point A and touches the x-axis. Show that the locus of other end of diameter through A is x minus a whole square equals 4by, which is a parabola. Now first we'll draw the axis, and then we have this circle which touches x-axis. And it passes through this point A, which is A comma B, and we have to show that locus of other end of diameter. So you have to find locus of this point. Now in locus, first step is identify the point. We have to find locus of this point. So let this point be alpha comma beta, and this is your center, and since it touches x-axis, that means perpendicular distance from the center to this x-axis, it must be equal to its radius. Now we'll find coordinate of the center. Coordinate of the center will be alpha plus a by 2 and beta plus b by 2. Now we'll write radius for the circle, and it will be this 1 by 2 AB, and AB is under root of alpha minus A square plus beta minus B square. Now, since this circle, it touches x-axis, that means this radius, it must be equal to modulus value of its y coordinate, and which is beta plus b by 2. So basically this r will be equal to beta plus b by 2. Now this 2 and 2 will cancel. We square it, we can write alpha minus a square plus beta minus b square, and it will be equal to beta plus b square. Now this is alpha minus a square plus beta square plus b square minus 2b beta, and it will be equal to beta square plus b square plus 2b beta. Now these two, they'll cancel. So we'll get this locus as alpha minus a square equals 4b beta, and in the end we'll replace alpha with x and beta with y. So this locus will be x minus a whole square equals 4by, which is what we need to prove in this question. Now here the question is, tangents are drawn to these concentric circles x square plus y square equals a square and x square plus y square equals b square. So we have two concentric circles. Radius of this first circle is say a, and radius of the second circle is say b. That says these tangents are perpendicular to each other. We need to show that locus of that point of intersection is a third concentric circle, and we have to find its radius. Now it says we have to find locus of this point P such that tangents drawn from it to the two circles, they are perpendicular. So since this is a locus problem, we'll choose this point to be some alpha beta. Now this distance is a, this is b, and this is origin 0, 0. Now this angle is also 90 degrees, and since it is a rectangle, this is a and this is b. Now this distance will be under root of a square plus b square. So basically this OP, it is fixed and it is under root of a square plus b square. Now OP is under root of alpha square plus beta square, and it will be equal to under root of a square plus b square. So this locus will be alpha square plus beta square, and it will be equal to a square plus b square. Now we'll replace alpha with x and beta with y. So equation of this circle will be x square plus y square equals a square plus b square, which again is this third concentric circle whose radius is under root of a square plus b square. Now here the question is, we are given 2 points A and B, and C is a point which divides AB in a constant ratio 10 alpha. If AC and CB subtend equal angles at P, prove that equation of locus of P is this circle x square plus y square plus 2ax secant 2 alpha plus a square. Now here we have 2 points lying on an x-axis. This point A, it is minus a comma 0, and the point B is a comma 0, and then we have this point C which divides it in the ratio 10 alpha is to 1. Now coordinate of this point C will be mx2 plus nx1 upon m plus n. So there will be a 10 alpha minus 1 upon 10 alpha plus 1 comma 0, and then we have this point P such that AC and CB, they subtend equal angles at P. So AC and CB, they subtend equal angles, and we have to find locus of P. Now if they subtend equal angles, that means this PC, it is an angle bisector. Now since it is a locus question, we'll assume this P to be h comma k. So we'll let P as h comma k. Now we know the angle bisector property that PA upon PB will be equal to AC upon BC, and AC upon BC is actually tan alpha. So we can simply write PA is equal to PB into tan alpha. Now distance of P from A is this under root of h plus A whole square plus k square, and this is equal to tan alpha under root of h minus A whole square plus k square. Now we can square it. Then we can write this as h square plus A square plus 2HA plus k square, and it will be equal to h square plus A square minus 2AH plus k square into tan square alpha. Now what we'll do is we'll take everything on the left hand side and we'll take h square, A square and k square together. So it'll be this h square plus k square plus A square into 1 minus tan square alpha plus 2AH 1 plus tan square alpha, and it will be equal to 0. Now we'll divide everything with 1 minus tan square alpha. So we can write this as h square plus k square plus A square plus 2AH 1 plus tan square alpha upon 1 minus tan square alpha, and it will be equal to 0. Now 1 minus tan square theta upon 1 plus tan square theta is cos 2 theta. So this expression is secant 2 theta, which in this case is secant 2 alpha. So we can write this equation as h square plus k square plus A square plus 2AH secant 2 alpha equals to 0. And in the end, we'll replace h and k with x and y. So this equation, it will be x square plus y square plus 2ax secant 2 alpha plus a square equals 0, which is what we need to prove in this question. Now here the question is, find the locus of midpoints of the chord of the circle such that the segment intercepted by the chord on the curve subtends a right angle at the origin. The first step is identify the point. So this point is midpoint of chord of a circle. So let this midpoint be P, and it is given by this alpha comma beta. Now we know that if we are given midpoint, then we can write equation of this chord as T equals S1. Now this T will be alpha x plus beta y minus 4, and that will be equal to alpha square plus beta square minus 4. Now this 4 and 4 will cancel. So equation of this chord will be alpha x plus beta y equals alpha square plus beta square, or we can write this as alpha x plus beta y upon alpha square plus beta square. It is equal to 1. Now this chord, it intercepts this segment which subtends a right angle at origin. So what we'll do is we'll find equation of this pair of straight lines, and we get this equation of pair of straight lines by making this curve homogeneous. So we have this curve which is x square minus 2x minus 2y equals 0, and we have to make it a homogeneous curve in degree 2. Now this degree is already 2, here the degree is 1, and here also the degree is 1. So what we'll do is we'll actually write this as x square and then minus 2 x plus y and into 1, and we'll write this 1 as alpha x plus beta y upon alpha square plus beta square, and it is equal to 0. Now this is alpha square plus beta square x square and then minus 2, and this is alpha x square plus beta xy plus alpha xy plus beta y square equals 0. Now since these pair of straight lines, they are perpendicular, that means coefficient of x square plus sum of coefficient of y square, it must be 0. Now coefficient of x square is this term and this term, so it will be this alpha square plus beta square minus 2 alpha and plus coefficient of y square, and coefficient of y square is simply minus 2 beta equals 0, and that's the required locus. Now we'll replace alpha with x and beta with y. So equation of locus of midpoint of the chord of the circle will be this circle, which is x square plus y square minus 2x minus 2y equals 0. And that is the answer to this question. Now we have this circle whose center is at 2, 2 and radius is also 2. So this circle, it touches both the axes. And it says this circle is inscribed in a triangle which has two of its sides along the coordinate axis. So we have this triangle which circumscribes this circle. Now this is 90. Now we have to find locus of circumcenter of this triangle. Now let this point be h comma k, and since it is circumcenter, it is midpoint of this line, say AB. So basically a by 2 is h. So this a is 2h comma 0 and b is 0 comma 2k. Now equation of this line will be x upon 2h plus y upon 2k, it is equal to 1, and this line, it is tangent to this circle with center at 2, 2 and radius 2 units. That means perpendicular distance from the center must be equal to its radius. Now perpendicular distance from the center will be simply 1 by h plus 1 by k minus 1 upon under root of 1 by 4h square plus 1 by 4k square, and it should be equal to its radius, which is 2 units. Now we can write this as h plus k minus hk upon, and here it will be under root of h square plus k square, and we can take this 2 here and it is equal to this 2, and we have this mod sign. Now this 2 and 2 will cancel. We can write this as h plus k minus hk will be equal to plus or minus under root of h square plus k square. So this required locus will be x plus y minus xy plus minus under root of x square plus y square equals 0. Now basically here we are looking for one value of k, not two values of k. If we look at, now we look at this equation, which is x upon 2h plus y upon 2k minus 1 equals 0. Then origin and 2, 2 they lie on the same side. So for origin this is less than 0, and for 2, 2 it will be 1 upon h plus 1 upon k minus 1 will be less than 0. And if it is less than 0, then the only sign that we have here is this minus sign. So in that case, this equation will be x plus y minus xy plus under root of x square plus y square equals 0. That is, the value of k is simply 1. So in this case, value of k is 1 and not plus minus 1. Now here the question is, the chords of contact of the pair of tangents drawn from each point on this line to this circle pass through the point. So let this point be h comma k, and since it lies on this line, we'll get 2h plus k, and it is equal to 4. Now we know that equation of chord of contact is given by t equals 0. So for this circle, it will be hx plus ky, and it is equal to 1. Now we'll put k as 4 minus 2h. So we'll write this as hx plus 4 minus 2hy equals to 1. Now we can rewrite this as 4y minus 1 plus h, and then x minus 2y equals 0, where this h, it is a parameter. Now this is L1 plus lambda L2 equals to 0. That means it represents a straight line passing through point of intersection of L1 and L2. So that fixed point will be intersection of these two lines. Now first line is 4y minus 1 equals 0, and the other line is x minus 2y equals 0. So from here we'll get the value of y as 1 by 4 and value of x will be 1 by 2. So this fixed point will be 1 by 2 comma 1 by 4. Now here the question is, consider a curve ax square plus 2hxy plus by square equals 1. So we have this curve which is ax square plus 2hxy plus by square equals 1, and a point P which does not lie on this curve, and a line is drawn from this point P intersecting this curve at points Q and R. So we have this point P and a line through P, it intersects the curve at Q and R. That says if the product PQ and PR is independent of the slope of the line, then show that the curve is a circle. So what we'll do is, for this question we'll use parametric equation of this line. So let this point be x1 y1, and let the angle this line makes with positive x-axis be theta. So any general point on this line, we can write this as x minus x1 upon cos theta equals y minus y1 upon sin theta, and it is equal to r, where r is distance from this point. Now suppose distance of Q is r1 and distance of r is r2. Now any general point, we can write this as x1 plus r cos theta and y1 plus r sin theta. Now we are interested in finding the points which lie on this curve. So what we'll do is we'll put the value of x and y in this equation. So it will be this a x1 plus r cos theta square plus 2h x1 plus r cos theta y1 plus r sin theta, and plus b y square is y1 plus r sin theta whole square, and it is equal to 1. Now we'll simplify this equation. So it will be this a x1 square plus r square cos square theta plus 2 x1 r cos theta plus 2h x1 y1 plus x1 r sin theta plus y1 r cos theta plus r square sin theta cos theta plus, here it is y1, b into y1 square plus r square sin square theta plus 2r y1 sin theta equals 1. Now what we'll do is we'll write this as a quadratic equation in R. So we can write this as r square, and here will be this a cos square theta plus 2h sin theta cos theta plus b sin square theta plus, and then we write terms containing r. So there will be this r, and we have 2a cos theta plus 2h x1 sin theta plus 2h y1 cos theta plus 2by1 sin theta, and then this constant term which is a x1 square plus 2h x1 y1 plus b y1 square minus 1 equals 0. Now since this line, it intersects the curve at 2 points, this equation will have two roots, R1 and R2. Now it says the product PQ into PR, it is independent of slope. It is independent of theta. Now basically PQ into PR is R1 into R2, and which is nothing but product of roots. And product of roots is C upon A. So which is AX1 square plus 2H X1 Y1 plus BY1 square minus 1 upon this A cos square theta plus 2H sin theta cos theta plus B sin square theta. Now it has to be independent of theta, and it will be independent of theta if this term it is 0. So basically we'll get H equals 0, and if H equals 0, we'll get A cos square theta plus B sin square theta, and we can eliminate theta if A is equal to B. So if A is equal to B, then cos square theta plus sin square theta will be 1. So then it will be simply AX1 square plus 2H X1 Y1 plus BY1 square minus 1 upon A plus B, which is independent of theta. So for this curve, this product PQ into PR, it is independent of the slope if H is 0 and A equals B. Now if H is 0 and A equals B, we can write this equation as A x square plus y square equals 1, which is basically equation of a circle. So this curve, it is a circle. Now here the question is, a circle of radius 2 units rolls on outside of this circle x square plus y square plus 4x equals 0. Now center of the circle is at minus 2 comma 0 and its radius is 2 units. Touching it externally, find the locus of center of this outer circle and also find the equation of common tangents to the two circles when the line joining the centers of two circles makes an angle of 60 degrees with the x-axis. So we have our coordinate axis, and then we have this circle with center at minus 2 comma 0 and radius equals 2 units. This is minus 2 comma 0, that's your origin, and its radius is 2 unit. And then we have another circle which rolls on it, and suppose this angle is 60 degree and its radius is also 2 units. Now we know that center of this circle will move along this concentric circle. So locus of its center will be a circle with center at minus 2 comma 0 and its radius will be this 2 plus 2 4. So its equation will be x plus 2 square plus y square equals 4 square, or simply x square plus y square plus 4x minus 12 equals 0. Now it says also find the equation of common tangents to the two circles when the line joining centers of the two circles makes an angle 60 degrees with the x-axis. Now I'll have two direct common tangents, and since both of them they have same radius, slope of both the tangents will be this tan 60, which is root 3. Now we can write this as plus 4 4. So this equation will be x plus 2 whole square plus y square, that is equal to 2 square. So equation of tangent with slope root 3 will be given by y equals root 3 x plus 2 plus minus r under root 1 plus m square, and 1 plus m square is 3. So we'll get this as y equals root 3x plus 2 root 3 plus minus 4. So equation of these two tangents will be given by root 3x minus y equals plus minus 4 minus 2 root 3. And now we have to find equation of this tangent at their point of contact. Now this is 90 This angle is 60. So this angle will be 30. This angle is 150 degrees. So slope of this line will be minus 1 by root 3. And radius of this circle is 2. So this point, it will be minus 2 plus 2 cos 60 and 2 sin 60. So it will be this minus 1 comma root 3. So once we have slope and point, we can write equation of this tangent, and that will be y minus root 3 is equal to m x plus 1. So we get this as root 3y minus 3 minus x minus 1, or simply x plus root 3y equals 4. So these are the equation of 3 tangents to the 2 circles. Now the question is, tangents are drawn at any point x1, y1 other than vertex on the parabola, then if tangents are drawn from any point on this tangent to the circle such that all the chords of contact pass through a fixed point x2, y2, then which of the following is correct? Now in this question, this point x1, y1, it lies on this parabola, and we know that equation of tangent, if the point lies on the curve, it is given by t equals 0. So equation of this tangent will be given by y1 4a x plus x1 by 2. So it will be this 2ax minus y1 plus 2ax1 equals 0. Now suppose a point on this tangent is this point P, which is h comma k, so we'll get 2ah minus y1k plus 2ax1 equals 0, and that's our first equation. Now from this point, if we write equation of chord of contact to this circle x square plus y square equals to a square, we know that chord of contact is given by t equals 0. So we'll get this equation as hx plus ky, and it is equal to a square, and it says the chord of contact will pass through this fixed point x2, y2. So we can write hx2 plus ky2, it is equal to a square. Now these two equations, they represent the same line. So we'll have 2ah minus y1k plus 2ax1 equals 0. So from here we can write 2a upon x2 will be equal to minus y1 upon y2 2ax1 upon minus a square. Now if we take these first two conditions, then we can write x1 x2 equals minus a square. That means this option A, it is incorrect. So x1 a x2, they cannot be in GP. Now we also know that this point x1 y1, it lies on this parabola. So we have y1 square is equal to 4a x1. So if we solve these first two, we can write minus x2 y1, it is equal to 2a y2. Now we'll multiply this with y1. So we'll write minus x2 into y1 square, and this is 2a y1 y2. Now y1 square is 4a x1. So this is minus 4a x1 x2, and this is 2a y1 y2. Now x1 into x2 is minus a square. So here it will be y1 y2, it is equal to 2a square. Now we can rearrange this as y1 upon 2 into y2, it is equal to a square. That is y1 by 2, y2 and a, they are in GP. So this is your option B. And if we add x1, x2 and y1, y2, we'll get x1, x2 plus y1, y2 will be minus a square plus 2a square. That should be a square, and that's your option D. Now, what about this option C? Now, for the C part, we'll take these two. So, we'll have 2a equals minus x2 y1 upon y2. And if we take these two, then we'll have a by 2 equals x1 y2 upon y1. Now we'll put the value of a in this, then we can write 2 times, and this a is 2 x1 y2 upon y1, and it will be equal to minus x2 y1 upon y2. Now we can write this as y1 upon y2 whole square, and this is minus 4 x1 upon x2, which is minus 4 y1 upon y2 and x1 upon x2. They are in GP. That means this option C is also correct. So the correct options are B, C and D. Now here the question is, let R and S be the diameter of the circle where S is this point 1, 0. Let P be a variable point other than RS on the circle, and tangents to the circle at S and P meet at point Q. The normal to the circle at P intersects a line drawn through Q parallel to RS at point E. Then locus of E passes through which of the following point? So we have this circle with center at origin. Now this point S, it is 1, 0. Then basically this point R, it is minus 1, 0. Then we have a variable point P on this circle, and suppose this P is cos theta, sin theta. Now equation of tangent is given by t equals 0. So we'll get this as x cos theta plus y sin theta equals to 1. So it has this tangent, and it says tangent to the circle at S and P meet at this point Q. So if we draw a tangent at this point S, these two tangents, they meet at this point Q. Now tangent at S, it is simply x equal to 1. So coordinate of this point Q will be 1, 1 minus cos theta upon sin theta. Now 1 minus cos theta is 2 sin square theta by 2, and this is 2 sin theta by 2 cos theta by 2. So we can also write this as 1, tan theta by 2. Now it says the normal to the circle at P intersects the line drawn through Q parallel to RS at point E. So normal through P intersects a line drawn through Q parallel to RS at point E. So we have drawn a line at this point Q, and this line is y equals tan theta by 2, and it intersects at this point E, and we have to find locus of E. So this point is alpha, beta. Now if we write equation of OP is simply y equals tan theta x. Since this line is parallel to x-axis, its y coordinate is tan theta by 2, so we can write beta as tan theta by 2, and alpha will be beta upon tan theta, so there will be tan theta by 2 upon tan theta. Now first we have to find locus of this point E. Now beta is tan theta by 2, so we can write beta upon alpha as tan theta, and tan theta is 2 tan theta by 2 upon 1 minus tan square theta by 2. Now tan theta by 2 is beta. So we can write this as beta upon alpha, and this is 2 beta upon 1 minus beta square. Now this beta square will cancel. So this locus will be 1 minus beta square equals 2 alpha. We'll replace beta with y and alpha with x. Then we can write y square equals 1 minus 2x, which is a parabola. So locus of this point E, it is this parabola y square equals 1 minus 2x. Now it says which of the 4 points will lie on this parabola. Now we look at this point A. Its coordinate is 1 by 3 under root 1 by under root 3. So if we put y as 1 by root 3, will be this 1 by 3, and 1 minus 2 by 3. It satisfies this equation. So this option A is correct. Now for this option B, we have 1 by 4 and 1 by 2. So this is 1 by 4 and this is 1 minus 1 by 2, not equal. So this option B is incorrect. Point C is 1 by 3 minus 1 by root 3. So this is 1 by 3 and 1 minus 2 by 3, which again is true. So option C is correct. And then this option D, where we have 1 by 4 and minus 1 by 2. So it will be this 1 by 4, 1 minus 1 by 2. This is incorrect. So the correct options are A and C. Now here the question is, let L1, L2 and L3 be the lengths of tangents drawn from the point to the circles respectively. And if we are given L1 to the power 4 equals L2, L3 square plus 16, then locus of P are the curves C1, which is a straight line, and C2, which is a circle. So first we'll simplify this. Now suppose this point P is alpha beta, then we know that L1 square, it will be alpha square plus beta square minus 4. L2 square will be alpha square plus beta square minus 4 alpha, and L3 square will be alpha square plus beta square minus 4 beta. Now we are given that L1 to the power 4, that means alpha square plus beta square minus 4 whole square, it is equal to alpha square plus beta square minus 4 alpha into alpha square plus beta square minus 4 beta plus 16. Now we'll take this as first term and minus 4 as second term. We can write this as alpha square plus beta square whole square plus 16 minus 8 alpha square plus beta square, and here also we'll take this as one term. So it will be this alpha square plus beta square whole square minus 4 alpha plus beta into alpha square plus beta square, and then plus 16 alpha beta plus 16. Now here alpha square plus beta square will cancel, and this 16 will also cancel. Now we'll take 8 alpha plus beta whole square on the right hand side. Then we can write this is 8 alpha plus beta whole square minus 4 alpha plus beta into alpha square plus beta square equals 0. And here we'll take 4 common. Then we can write alpha plus beta into 2 alpha plus 2 beta minus alpha square minus beta square equals to 0. So the required locus, it is either this straight line x plus y equals to 0, which is given as this curve C1, or this circle C2, which is x square plus y square minus 2x minus 2y equals 0. Now this first question is circumcenter of the triangle formed by C1 and other two lines which are at an angle of 45 degrees with C1 and tangent to C2 is. So we have this circle whose center is at 1, 1 and radius is √2. So it will be this circle passing through origin, center at 1, 1. And we also have this line x plus y equals 0. If we look at equation of tangent to this circle at 0, 0, it will be this 0x plus 0y minus 2 x plus 0 upon 2 and minus 2 y plus 0 upon 2 equals 0. We'll get this equation as x plus y equals to 0. So basically this C1, it is tangent to this circle at origin. So we have this line which is C1 and this equation is x plus y equals 0, and here this angle is 45 degrees. Now the lines which makes an angle 45 degrees with C1, there will be lines which are parallel to x-axis and y-axis. So we'll have these two lines. So we are talking about this triangle. Now suppose this is A, B, C. Now this angle A, it is 90 degrees. Then basically it is midpoint of BC. So this is midpoint of BC, which is circumcenter of this triangle ABC. And clearly midpoint of BC is at origin. So circumcenter of this triangle ABC, it is origin, and that's your option B. We can work this out also. Now we know that this is 45. This is 45. Now equation of this line is x equals 1 plus root 2. And equation of this line is y equals 1 plus root 2. So coordinate of this point A is 1 plus root 2 and 1 plus root 2. Now for this line, if we put x as 1 plus root 2, we'll get y as minus 1 plus root 2. So it will be 1 plus root 2 comma minus 1 plus root 2. And here we know y is 1 plus root 2. And we put y as 1 plus root 2, x is minus 1 plus root 2. And if we find its midpoint, it will be at origin. So which is again same as this option B. Now this second question is, if S1, S2 and S3 are three circles congruent to C2 and touch both C1 and C2, then area of triangle formed by joining centers of S1, S2 and S3 is. So now basically we have C1 and C2, and it says we have three circles which are congruent to this C1 and which touches both C1 and C2. So one of the circle will be drawn like this, and since it is congruent, it will have same radius, and there is a circle, it will be drawn like this, and we have this third circle which should be drawn like this. And suppose their centers are S1, S2 and S3. Now since these circles, they have same radius, we can join line joining these centers. And this is a perpendicular. Now this point is suppose P. Then we know that S1P is 2R and radius of both the circle is root 2. So there will be 2 root 2, and S2, S3, it is 4R, which is 4 root 2. Then area of this triangle will be this 1 by 2, 2 root 2 into 4 root 2, which is simply 8 square units. So area of this triangle is 8 square units, and that's your option C. Now the question is, fxy equals to 0 be the equation of a circle such that f0, y has equal roots and fx, 0 has two distinct real roots. And if angle between the tangents drawn from point P to fxy equals 0 is pi by 3, then locus of P is a circle whose equation is x square plus y square minus 5x minus 4y plus c equals 0. Let Q be a point from which tangents to gxy equals to 0 are perpendicular, and AB is chord of contact of Q with respect to gxy equals to 0. Then solve the following question. So we have this circle and whose equation is fxy equals 0. And we have this point P outside of the circle, from which we have drawn two tangents, P and PB. Now this angle is pi by 6. If we drop a perpendicular, this is radius r, and suppose center is hk and point P is alpha beta. So we can write r upon Cp, that will be equal to sine pi by 6, 1 by 2. So Cp is 2r. Now this P is suppose alpha comma beta. So we can write alpha minus h whole square plus beta minus k whole square, and will be equal to 4r square. Now we'll write locus of P. So we'll replace alpha with x and beta with y. So it will be x square plus y square minus 2hx minus 2ky plus h square plus k square minus 4r square, and will be equal to 0. Now we'll compare it with the given equation, which is x square plus y square minus 5x minus 4y plus c equals 0. Now we compare it directly, we'll get 2h equals 5 and 2k equals 4. So this fxy equals to 0 will be x square plus y square minus 5x minus 4y plus lambda equals 0. Now it is given that f0 comma y has equal roots. So if you put x as 0, we'll get this as y square minus 4y plus lambda equals 0. So from there we'll get value of lambda as 4. So once we have this lambda, we can write fxy as x square plus y square minus 5x minus 4y plus 4 equals 0. And that's your option D. Now center of the circle is 5 by 2, comma 2. And its radius is 5 by 2. We have this point P, which makes an angle 60 degrees. So this angle is 30 degrees. Now this is 5 by 2. So this CP will be simply 5. So gxy equals 0 will be x minus 5 by 2 square plus y minus 2 square equals 5 square. So this is the equation of gxy equals 0. Now we have to find area of triangle QAB. And Q is point from where tangents to gxy are perpendicular. So this Q will lie on director circle of gxy. And AB is chord of contact of Q with respect to gxy equals 0. So from Q, perpendicular tangents are drawn to gxy. Now radius of gxy is 5. This angle is 45 because entire angle is 90 degrees. So this is also 5. And in this right angle triangle, we can write QR as 5 by root 2. So we'll get this QR. So this AR is 5 by root 2. That means this AB is 5 root 2. So the area of this triangle will be 1 by 2 into 5 by root 2 into 5 root 2. Now this root 2 will cancel. So it will be this 25 by 2, and that's your option A. Now this third one is length of x-axis intercept made by gxy equals 0. Now length of x-axis intercept is 2 times under root g square minus c. So this is 2 times under root, and this is 5 by 2 square, 25 by 4 plus 59 by 4. And that will be 2 root 21 or under root 84. And that's your option B. Now here the question is, tangents PA and PB are drawn to this circle from the point P on the curve y equals sin x. So we have our coordinate axis, and this is the circle with center at 4, 5 and radius equals 2, and this other curve is your sine curve. Now it says, from a point P on this curve, tangents PA and PB are drawn. So we have drawn two tangents from any point on this sinusoidal curve to this circle where points of contact are A and B. Now it says, this function y equals fx, it represents locus of center of circumcenter of triangle PAB. So we will find locus of circumcenter of this triangle PAB. Now we know that circumcenter of this triangle PAB is going to pass through center of this given circle, and this PC, it will be diameter for that circle. So suppose this point is M and its coordinate is alpha beta. We will find locus of M. Now we'll assume, let P be h comma k. So basically k will be equal to sin h. Now this M, it is midpoint of PC. So this alpha will be h plus 4 by 2 and beta will be k plus 5 by 2. Now what we'll do is we'll put the value of h and k in this equation. So this k will be 2 beta minus 5 and it will be equal to sine 2 alpha minus 4. So this required locus of circumcenter will be this y equals 1 by 2 sine 2x minus 4 plus 5 by 2. So that's your curve y equals fx. Now this first question is, find the range of fx. Now we know that minimum value of sin theta is minus 1. So minimum value of y will be minus 1 by 2 plus 5 by 2, which is 2, and maximum value of y will be 1. So it will be this 1 by 2 plus 5 by 2, 3. So range of this function will be from 2 to 3, and that's your option D. Now this second question is, find the period of this function y equals fx. Now it is a sine function, so its period will be given by 2 pi divided by coefficient of x, which is 2. So this function is periodic with the period pi, and that's your option C. And then this third one is, which of the following is true? Now this A is fx equals to 4 has real roots. Now we know that range of fx is 2 to 3. So this fx, it cannot take the value 4. So this option A is obviously incorrect. Now B is fx equal to 1 has real root. Now again 1, it doesn't lie in the range. So this B is also incorrect. Now C is range of f inverse x. Now if we find its inverse function will be 1 by 2 sine inverse 2x minus 5 plus 2. Now we have sine inverse function here. Minimum value of sine inverse is minus pi by 2. So its minimum value is 2 minus pi by 4, and its maximum value is when sine inverse x is pi by 2. So it will be this 2 plus pi by 4. So range of its inverse function is from 2 minus pi by 4 to 2 plus pi by 4. That means this option C is correct. So the correct option is this option C.